So these are the classified questions related to topic waves. Yesterday we completed about page 20. So weekly now, my plan is to do some classified questions from topics. Like this week, we took waves in both sessions. Next week, we will do electric circuits. In page 21, by reference to two waves, state the principle of a superposition. What is a superposition principle? Superposition principle state that when two progressive waves, like two waves, which meet at any point, the resultant of the two waves will always be equals to algebraic sum of the two. Like when we say algebraic sum of the two, it means like when we add them, we get the total. So when two waves, two progressive waves meet at any point, the resulting displacement will be equals to the sum of each wave or algebraic sum of the two waves. So when two waves meet at any point, the resultant wave displacement is algebraic sum of the two. What is meant by coherence? So what is the meaning of the term coherence? The term coherence means that the two waves have a constant phase difference. When the two waves have a constant phase difference, we call them as coherence. And I gave an example, like if we have, let's say, source 1 is there and we have source 2. We will say the waves are coherence, like every time if the crest is coming out from here and every time trough is coming out from here, so it will remain like this. It won't change. But we say they're incoherent if the one is emitting out crest, the other is for emitting out trough, then crest, then trough. So it's continuously changing. What we say it is not having a constant phase difference. So these are the incoherent sources. Two coherent waves P and Q meet at a point in phase and superpose. The wave P has an amplitude of 1.5 centimeter and intensity I. The resultant intensity at a point where the wave meet is 3I. Calculate the amplitude of a Q. So let's say we have a P is 1 and Q. They meet at a point. So crest, and their dimension in phase. So when they're in phase means the crest joined with the crest or the trough joined with the trough. Because when crest joined with the crest or a trough joined with the trough, we'll get the same resultant wave or amplitude will increase. In the question, the amplitude, when a P has an amplitude of 1.5, intensity is I. And what is the relation between the intensity and amplitude? Intensity is directly proportional to amplitude square. Or we can also say intensity divided by amplitude square is always equals to constant. Like the ratio of intensity, because when two quantities are directly proportional, their ratio should be constant. So means the ratio of intensity over amplitude square should be constant here. For P, and same thing, the ratio of the intensity and amplitude square for the Q should also be constant. So the resultant intensity at a point where the wave meet is 3I. So the result of these two intensities, like when they combine with each other, the resultant is 3I. We have to calculate the amplitude of the Q. So how we can work out the amplitude of the Q? what the amplitude of the resultant wave will be there? Because P has an amplitude of 1.5 and Q has an amplitude. We don't know the amplitude of the Q. Like for P, this distance is 1.5. For Q, this distance is, let's say it's A, because we don't know its amplitude. It produces a resultant wave, like this is a resultant wave because of the combination of P and Q. So what is the amplitude of the resultant wave? The amplitude of the resultant wave as they're in phase. So this is A and this is 1.5. So amplitude of the resultant wave will be A plus 1.5. Because they are in phase. When the two waves are in phase and we need an amplitude. So if this distance was A and this distance was B, so the resultant amplitude as they're in phase, that is equals to A plus B, the sum of the two. So if this one is amplitude 1.5 and here we don't know its amplitude, we called A. So the total resultant amplitude will be A plus 1.5. And we just simplify this because in the question we know the resultant, we know the intensity of this resultant. What is the intensity of the resultant given in the question? The intensity of this resultant is 3I. So we know the amplitude and the intensity of this wave, the resultant wave, and we know the amplitude and the intensity of the first wave. We need for the second wave. So we are comparing P and the resultant wave. So the ratio of the amplitude because they're constant, so intensity of the first wave, like P divided by its amplitude, which is 1.5 square, will be equals to the intensity of the second wave, which is 3I. So 3I square, 3I divided by the amplitude of this resultant wave. So what is the amplitude of the resultant wave? It is 1.5 plus A square. So why we are comparing P with the resultant? Because we know the amplitude of the P and we know the intensity of a P. And we have the intensity and amplitude of the resultant as well. Now you just have to simplify this equation and make a subject A. So I will cancel with I. 1.5 square will be multiplied. So this will be 1.5 plus A in a whole square is equals to 3 times 1.5 square. And just take a root, under root. So if I take a root here, so it will be 1.5 plus A is equals to root 3 times 1.5 square. And if I need A will be equals to under root 3 times 1.5 square minus 1.5. What's the answer for A? The amplitude. What is the amplitude of the Q? I did not convert the unit, like the final answer will be in centimeter. So it's coming out as 1.1. Yeah, so 1.1 centimeter. Is it clear how we worked out this? So what actually we compare? We compare the resultant wave with one of the original wave. If this was the same question, and they said instead of in phase, if it was out of phase, and definitely the intensity will not be 3I, it will be less than, like it might be something I by 2, as the two waves will be anti-phase. So in that case, if this was a P and we have a Q, and they cancel out the effect of each other, they will give any resultant wave. The intensity of, let's say, this resultant wave is I by 2. And what about amplitude of this resultant wave? If the amplitude of the P was given 1.5 and amplitude of Q was not given, so we'll take as A. So in that case, we'll take the amplitude as 1.5 minus A, or A minus 1.5 for the resultant. A minus 1.5 or 1.5 minus A. Both cases it will be the same. Only the final answer will vary with the value. Like I mean the sign, but not the magnitude. So when they're anti-phase, we subtract their amplitudes to get the result. When they're in phase, we add their amplitude to get the resultant wave. Next question is related to the double slit. So in a double slit experiment, lambda is equals to AX over D, where A is the spacing between the two slits, D is the distance between the double slit and the screen, and X is what? It's a spacing between the two successive fringes. So this is a direct question. A light wave with a wavelength of 680 nanometer, so 618 to 10 power minus 9, is incident on a double slit. The slit separation is A. The separation between the adjacent fringes is X. The fringes are viewed on the screen a distance D from. Then in the question, the distance D is varied from 2 meters to 3.5 meter. The variation with D and X is shown. Actually, it's like a ratio of X and D, because when I take a gradient here, as we have the formula, lambda is equals to AX over D. So if I have a quantity on y-axis, divide by quantity on x-axis, when I take a gradient, it will be y over x. So I will get the value of x over d. Use the figure to determine this A. So if we want to determine the A, what we can take here, first we will take a gradient, but one thing in mind, because the unit is given in millimeter, don't forget to convert into meters. So you take out the gradient, like it's starting from 4 and ending around, this is 6, 10 boxes equals to 4, so each is 0.4. You can also do one thing, like if you don't want to take a gradient, you can take another thing, like you can take a single value, it will also work. Because the variation, the ratio is the same. For a single value of x, I need a single value, specific value of d, like lambda is equals to ax over d. So what else we can do? We can also use like value of x. For that value of x, what is the value of a d? If I take value of x, say I'm taking 4 millimeters, so the value of a d is equals to 2. If I take a value of x is equals to 6 millimeter, value of a d is about 2.9 or 2.95. So you can do direct method as well, because when you take a gradient, you know you will get the variation in the, like the average value will be there, but instead of that, direct value will work as well. So this is x and d. So just substitute lambda is equals to ax over d. So x is there from the graph, d is there, a you can work out, and the wavelength is already given in the question. So 4 exponent minus 3 times divided by 2. The wavelength is 680 nanometers. So you can just take these values, like lambda is equals to ax over d. So if I need a, it will be lambda d divided by x is equals to a. The wavelength is 680 nano. D is 2, and this is 4 into 10 to the power negative 3. So the value of A is 3.4 exponent minus 4. So A is equals to 3.4 into 10 to the power minus 4 meter. The next is the laser is now replaced by another laser that emit a shorter wavelength. On the figure, sketch a possible line to show the variation with D and X that are now produced. If you are using a shorter wavelength and A is the same, A is the spacing that is not changing. So because lambda is equals to A X over D, the wavelength is shorter. So means the ratio of X over D should also decrease. Because, or in short, you can say because A is constant, the spacing between the double slit is a fixed value. What the variation of a D and X we want to compare with a wavelength if we are using a shorter wavelength. So we want a graph line as a shorter wavelength is used. So the ratio of X over D should also decrease because A is constant. So ratio of X over D is actually the gradient of this graph. So we can just draw any line, a parallel line, but below this, which shows that the ratio of X over D is smaller for. So it should be a straight line will be there and it will be below the original one which we drew. And the gradient should also be smaller. I mean like because X over D is smaller. So the gradient should also be smaller. Like not parallel. If it is parallel, it means the ratio is constant. We want a smaller lambda X over D. So that's why it should be less steeper. Is it clear? Then we have a principle of the superposition. The two waves are combining. State the principle of a superposition. It's the same repeated question. Try to learn the standard answer that when two progressive waves meet at a single point or at a point, the resultant displacement is a sum of individual displacement or algebraic sum of the two waves. Arrangement demonstrate interference. This is again a double slit is there. You have a bright and a dark fringes. This D is given. The 22 millimeters is space between how many consecutive fringes? Like this is 1, 2, 3, 4. So this is actually equal to 4x because each is x. So 4x is 22. So x will be equals to 22 divided by 4. That will be x. This D is given. Wavelength is also given. So you can work out A. What is meant by coherent? Again, the same repeated question. What is the meaning? The coherent means that there is a constant phase relation or a phase difference between the two waves, two progressive waves. State the phase difference at Q. What is the phase difference? Because Q is what? Q is a bright fringe. Whenever there is a bright fringe, what is the phase difference? The phase difference will be 0 or 360 degrees. Path difference will change, like the central maxima, 0 wavelength, then lambda by 2, then lambda, then 3 by 2 lambda, then 2 lambda. And as we go down, again lambda by 2, lambda, 3 by 2 lambda, and 2 lambda. These are the path differences. So the phase difference, what about the phase difference 0 or 360, 180, 0, 180, 0. Phase difference is like when they're in phase, 0 or 360 is the same thing. When they're in phase, you say 0, 360. When they're anti phase, you say 180. The next is calculate the path difference in nanometer for the waves meeting at P. At P, we need the path difference. P is a destructive interference. And what is the pattern here? It is actually like 3 by 2. It is 3 by 2 wavelength. So mean the part difference, it's a destructive interference, which is the part difference. 3 by 2 is the part difference. So 3 wavelength by 2, so 3 into 680, 610 nanometer. They mention calculated nanometer, so no need to convert the unit, divided by 2. So 3 by 2 of 610, that is equals to 920. So the part difference is equals to 920 nanometers. 915, okay. So the part difference is equals to 915 nanometer. Why we did not convert the unit, as they already mentioned, use nanometer as a part difference here. Determine the spacing between the two slits. So how you can determine? You need A here. So in a double slit, what is our formula? In a double slit, our formula is lambda is equals to AX over D. We need A, so it will be lambda D divided by X is equals to A. But what about X? As I mentioned, 22 millimeter is the distance for the 4. So 22 should be divided by 4 and it is in millimeter. So the lambda is 610 nanometer. D is the space between the 2.7, the screen and the double slit. And the X is 22 milli. So 22 into 10 to the power 3 divided by 4. Why not divided by 8? Because X is the spacing between the two successive fringes, like the bright fringes. So this is 1x, this is 2x, this is 3x, and this one is 4x. So that's why I did not divide it. X is not the width of one bright. X is actually a space between the two successive brights or two successive dark. So this is 1x, this is 2x, 3x, and 4x. That is 22. Is it clear? So X is not the width of the bright. X is a space between the two fringes. The next is a higher frequency of a visible light is used. Explain, state and explain the change to the separation of the fringes. If I use a longer wavelength, higher frequency means a shorter wavelength. So lambda is equals to AX over D. We are not changing these two. So if we are using a higher frequency, it means the wavelength will be shorter. If the wavelength is shorter, means the X or the spacing between the fringes will also decrease. So it means like we will have more bright and dark in this, like here we are having 4, but we will have more than 4, like 8 bright and dark are there, but we'll have more as the spacing decreases. The intensity of a light incident is double without altering the frequency. Compare the appearance of the fringes before and after. If we increase the intensity, what will happen? For a dark, there will be no change because dark remain dark. But for a brighter, what it will become? It will become much more brighter. But the spacing between the fringes does not change because lambda is equals to AX over D. This is not changing any factor, so X will remain same. But the dark remain dark because dark is like no light. They cancel out effect of each other. For a dark, there will be no change in intensity. Dark remain dark. But what happened to a bright? The bright will appear much more brighter. And the spacing won't change. Because the interference pattern happen as a wave have a constructive interference, they enhance the effect of each other. So if I use, like example, this is a constructive interference, so this will be the resultant amplitude. But they're saying if we increase the intensity, increasing intensity means we increase the amplitude. So if I use the same wavelengths, but a higher amplitude, so as a result, what will happen? The resultant wave will have a higher amplitude. So the bright will be much brighter than what it was originally. But what about the dark? Dark means they are cancelling out the effect of each other. How we know it is in phase? Because you can clearly see it's written a bright. A bright means they are constructive interference. And a dark means there's a destructive interference. No, dark become darker is not the right term. If I say in a room a light is switched off, and if I say surrounding is also dark, but it won't change the scenario. Dark remain dark. Dark means that they cancel out the effect of each other. So even if a wave of a 2 centimeter meet here and undergo a destructive interference, they cancel out. And a wave of a 5 centimeter amplitude meet here and they cancel out the effect of each other. So if they cancel out, even 2 centimeter, like 5 minus 5 is 2, 5 minus 5 is 0. So same 2 minus 2 is also 0. So both are giving a result 0. That's why the dark will remain dark. There's no change in the appearance of a dark, but the bright will appear much brighter. So don't write dark changes to much darker. Mention the dark remain dark, but the brighter will appear much brighter. Like the bright will appear much brighter because of a high amplitude of the resultant wave. Is it clear? Any question or a doubt related to the session today?